So in this video I'll be talking about physical pendulum. So this is only based on angular SHM. So basically if any body which is suspended from any point and if it can perform angular SHM, then it is said to be physical pendulum. Right? Suppose that we have let us take one example of rod. So we have a rod which is suspended from the one end. So this is the point of suspension, point A. Point of suspension. Right? This rod has, let's say, mass m, length l. So now suppose that what they are trying to say, if this can perform angular SHM, that means if we rotate this rod with certain angle theta, rod goes like this, and of course if it goes like this it will be coming back like this. So if we have rod like this here, then this will be the situation. So you can clearly see, if you displace this rod with an angle theta and if it is performing angular SHM, then we need to calculate the time period of that physical pendulum. Okay, so how to do it? So we have done the case of simple pendulum, likewise we need to do only. So suppose that here I am taking, this is our rod like this, though it will have little bit thickness, but I am trying to just make you understand. That's why I'm just taking like this, so that you'll not be feeling little bit uncomfortable. So let's say after getting displaced with angle theta, rod will be here. Now this time while writing torque, because in angular SHM you need to prove torque is equal to minus c theta, right? So if you have displaced theta angle, then restoring torque. So because for writing restoring torque you need to see the center of mass of the rod. So this point A, or let's say this point C, is the center of mass of the rod. Perfect. So now this will be displaced here when this rod will be at theta angle. So that means mass mg we have to consider at center of mass, right? Now this length is, let's say rod has ml, m mass, length l. So this length will definitely be l by 2. So if you draw the perpendicular here, let's say p, so let's say this is a, p, and this point is, let's say, c. So in triangle APC, what I observe, this angle is theta, this, let's say this distance is x, and this one is l by 2, this is AC, this is PC. So we can write PC upon AC is equal to sine theta, or PC will be equal to x, AC is l by 2, so l by 2 sine theta. Why I was actually calculating this? Because I know that perpendicular distance will be x we need. So if you write the value of if you write the value of restoring torque, then torque will be given as minus mg is the force, and obviously it is trying to restore this rod in this direction again. So mg into x, this can be written as minus mg into x is L by 2 sine theta. Perfect. Now here we have to assume similar things. Theta is small as we have seen in simple pendulum. So if that is true, then I can write sine theta will be approximately equal to theta itself. And if that is true, I can write this is minus mg into L by 2 into theta. So obviously this will become C. Okay, because we can compare torque is equal to minus C theta, right? So that is going to be the minus C theta. Now we know that the formula for angular SHM of time period will be is equal to T is equal to 2 pi under root of L by G. So that was for simple pendulum. So in angular SHM, formula for time period is T is equal to 2 pi under root of I by C. Instead of mass, you have to use moment of inertia, and instead of using K, you are using C here. So the value of I, so this rod is point of suspension was A, so IA will be ml square by 12, because we know that in rotation moment of inertia about center of mass will be ml square by 12, and if you apply parallel axis theorem, then you need to use md square. Here d will be is equal to L by 2, so this is ml square by 12 plus m into L square by 4, which gives you ml square by 3 only. So time period formula will be T is equal to 2 pi under root I by C. I is ml square by 3 divided by C. C is how much? mg into L by 2. So this m is cancelled out, L is cancelled out, 2 pi under root of 2L by 3g is the answer, right? So you can compare the result with simple pendulum, that was 2 pi under root of L by G, here 2L by 3G. Okay, one more way of doing this question is, if you do not remember the formula, which formula? This formula, then how to proceed? So you can in fact proceed from this point. We know that torque is equal to I, so this is torque about A we were writing, so this was torque about A, so I into alpha. Okay, so IA into alpha will become minus mg L by 2 into theta. Now we have already calculated IA, which is ml square by 3 into alpha minus mg L by 2 into theta, correct? So this is m cancelled out, L and L is cancelled out, so from here alpha can be obtained minus 3g upon 2L into theta, correct? And if you do that, then we know in angular SHM alpha is equal to minus omega square theta. So we can compare these two equations. On comparing alpha values, what do I observe? Minus 3g upon 2L into theta is equal to minus omega square into theta. This is cancelled out, theta and theta cancelled out. Omega is nothing else under root of 3g by 2L. And once I achieved the value of omega, then we know that time period is given by 2 pi by omega, which will be 2 pi by omega. So 1 upon omega is under root of 2L by 3g. Are we getting the same answer? Yes, 2 pi under root of 2L by 3g, and here also 2 pi under root of 3L by 3g. So both the methods are right. You can solve any kind of question now. So I would suggest you to remember this formula. Directly you can find out the answer easily. Okay, so this is your physical pendulum and question related to physical pendulums. Okay.